Derivatives of trig functions. So now we're throwing in what the derivative of a trig function is going to be. So the derivative of cosine is always going to be negative sine x. Always. The derivative of sine is always cosine x. And now we come with our reciprocal functions. So one thing that I'll show you is the tangent one. So tangent. We know that tangent is sine over cosine. So if I'm doing the quotient rule, if I take my denominator times the derivative of the numerator, which is cosine x, minus that numerator, sine x, times the derivative of the denominator, which is negative sine x, all over denominator squared. Okay? So up top in my numerator, I end up getting cosine x, cosine squared x, plus sine squared x. All over, I'm just going to write that as cosine squared x. What is cosine squared plus sine squared?
1.
It's going to be 1 over cosine squared x, which is secant squared x. The derivative of tangent is secant squared x. And that's what a college professor will show you, especially with that one, with the proof of it. You can do the same thing for cotangent. Cotangent ends up being negative cosecant squared x. Secant is secant tan. The derivative of secant is secant x tan x. And the derivative of cosecant is negative cosecant x cotangent x. And I could go through and prove every single one of them, but I'm not. I'm not going to go through and prove every single one of them. So that would just take up a lot of time. And in college, more than likely, they're going to prove the tangent one, possibly the cotangent, and then give you the other two. The derivative of e to the x is always e to the x. Those are the best ones. Nothing changes with the derivative. You can't change an exponential growth, basically. The derivative of ln x is just 1 over x. Okay? So those are the derivatives of those. Okay? So now if I'm coming over here and I'm finding the derivative of this function, so I'm finding my dy dx. You've got x times sine x. That's the product rule. So we're applying the product rule, where we're taking the first times the derivative of the second plus the second times the derivative of the first. And that's just for the x sine x. First times the derivative of the second plus the second times the derivative of the first. Now I'm going to do the same thing with the cosine x, cosecant x, plus the first times the derivative of the second plus the second times the derivative of the first. And for now, I'm just going to leave it because I just want to see you initially taking those derivatives. And then this one here. Can I rewrite that so I'm not using the quotient rule? I can rewrite this to 4 secant x. And I can rewrite the 1 over tangent to cotangent x. Now find the derivatives. The derivative of this would just be 4 secant x tan x, because that's the derivative of secant, plus the derivative of cotangent, so minus negative cosecant squared x. And I'm done. That's what you're going to be doing today. You're just dealing with tangents, cotangents, sines, cosines, cosecants, and cosines. Are these easy to memorize after a while? Yeah. They're pretty easy to get down.